Good day everyone. Today we're going to tackle about microscope magnification computations. In computing magnification or in computing microscope magnification, it is important to remember the word I am, wherein I is equal to A times M. I, A, and M is a variable which represents I as the image size, A is the actual size, and M is the magnification. This equation is very important, or it is an essential thing for you to remember this equation, wherein image size is equal to the product of actual size times the magnification. Or we can also use a triangle method, wherein we have this. We have the triangle, and what inside is we have I on the top, and we have A and M here at the bottom side. So for example, if we are finding for I, what we have is A times M. And if we are looking for A, or the actual size, we have I divided by M. And if we are looking for M, we have I divided by A. And for you to easily understand this concept or this magnification computations in Microscope, the first thing that I wanted to know is what are the things that Microscope magnify. One of the examples that Microscope magnifies is the cells, or it can be tissues, organs, bacteria, or microscopic things that can be observed under the microscope. Now, for us to easily understand the computation or the magnification computations, let's try this example. Calculate the actual size in millimeter. So we are going to calculate the actual size in millimeter. So you can see in the given or in the image, we have the given image size, which is this, a cell with the 90 millimeter image size with the magnification of times 8,000. First thing is we need to write the given. We have I is equal to 90 millimeter, and we have the magnification, which is 8,000. What we are looking now is the actual size, which is in millimeter. First thing is we need to use the equation I am. So we have I is equal to A M, and we are looking for the actual size. So we have this. Therefore, we have A is equal to I over M. So I, 90 millimeter divided by 8,000. We have now the actual size, which is 0.01125 millimeter. So that is the actual size. Let's try another example. Calculate the magnification. By this time, we have given the actual size, which is 0.003 millimeter, and we have given the image size, which is 30 millimeter. First, identify the given or write the given. We have I equals 30 millimeter, and we have given an actual size, which is 0.003 millimeter, and we are looking for the magnification. First, let's write the equation IM, and we are looking for magnification, so we are going to isolate the equation. Let's divide A on both sides. So we have now M equals to I over A. So we have 30 mm or millimeter divided by 0.003 mm. Let's divide it. We get now the magnification of times 10,000. Let's try another example. By this time, we are going to calculate the image size in millimeter. So as you can see, here is the cell. We don't know the image size, but we have given a magnification of 7,000, and we have given the actual size of 0.005 millimeter. First, let's write the given. We have given A, the actual size, which is 0.005 millimeter. We have the magnification of 7,000, and we are looking for the image size. First, let's write the equation IM. I is equal to A times M. Since we are looking for the image size, it is already given, or the equation is already suited. So let's just simply substitute the values. We have 0.005 millimeter times the magnification, which is 7,000. If we calculate it, the image size is 35 millimeter. To summarize the steps in computation, we need to analyze the image, then write all the given, and identify the missing variable. It should be I, A, or M. Then, write the equation. Remember the word IM. Then, isolate the equation based on what are we going to solve. After that, let's substitute, then compute, and find the answer. Thank you.